Hey there, POA. Let's get rolling. Let's have a conversation about proportional versus non-proportional relationships. Hopefully, a little slower than we had today in class. So let's just jump into it. So the terminology we're referring to is proportional versus non-proportional, and I'm not going to be able to necessarily redraw the entire table here, but I'll do a fair facsimile of it. Um, so if you have your table that you didn't quite get to fill out earlier today, now would be a great time to pull that table out because we are going to talk a little bit about proportional. Whoa. Versus non-proportional relationships. I'm going to talk about them in kind of several different ways. So one way we'll talk about them is terms of table. So what we kind of have to establish right off the bat is that we have a good example here of a proportional and a non-proportional relationship. The left-hand side being proportional, and the right-hand side being non-proportional. So if we're looking at characteristics, all we really have to do is examine the main differences here. And if we can do that, well, we actually have a list of ways we can not just tell proportional versus non-proportional, but really how these differences play out to a more useful end. So what we point out in class is that the biggest difference between, whoa, what's going on? Okay, here we go. All right, I don't know what's going on there. But the biggest difference between the table on the left and the table on the right has to do with where it kind of starts. And when I say starts, I mean starts when x equals 0. Okay? So if we look at the start value when x equals 0, we should notice that the y is equal to 0 as well. Over here on the non-proportional side, if we're looking at the start when x equals 0, we should notice that in the non-proportional side, we're now starting at 0, which is ultimately the quickest way to tell if you're dealing with a proportional or non-proportional relationship, with the assumption that, of course, it is linear, is where the table is starting when x equals 0. So if we drop down to your grid, to your notes, if you will, the way we can tell a proportional relationship on a table is when x equals 0, y equals 0. And a non-proportional side, when x equals 0, y does not equal 0. Now, if you're looking for an example, and if you're taking good notes, you guys should have an example here. If that's x, that's y. If that's 0, that's 0. And then from there, of course, doesn't really necessarily matter, etc., etc. Then over here on the non-proportional side, if we have x and we have y, if that's 0, that means this right here is anything but 0. Let's say it's a 5. And then from where you go from there, well, it doesn't necessarily matter. But the point being, this is the thing that makes it non-proportional. In the same way, that's what makes it proportional, at least in terms of linears. Now, I shouldn't say that's not what makes it proportional. That's how you can actually tell by looking at a table. All right. So not too shabby here. So again, we're looking just simply on the table where a little bit bigger. Okay. So we're looking at a table when x equals 0. Either we have a 0 across from it to make it proportional, or a not 0 to make it not proportional. Let's continue on. Let's extend this now. To look at graphs. Okay. So we pop up to the top. So the question really is, how does this like starting at 0 manifest itself now on a graph? Well, if I'm dealing with 0, comma 0, that's going to graph itself actually right here. So this point turns out to be precisely 0, comma 0. So a way we can say that what's happening is that it starts at the origin, or I should say passes through origin. Kind of in the same way, if we look at the non-proportional side, 0, comma 5 will actually manifest itself right here. that point is literally 0, comma 5. So this will not start at 0. In fact, it's going to start above or below 0. In other words, it's not going to go to the origin, will go somewhere else. So if we want to take note of that in our notes, if you will, we can tell something is indeed proportional if the graph passes through 0, or to say origin. And then, of course, we can tell something is not. Excuse me. We can tell something is non-proportional if the graph does not pass through origin. Okay. Now, again, if you're looking for an example, and if you're taking good notes, you should. What that kind of means is that for this graph, that's the part that makes it proportional, or at least how you can tell it's proportional. And the fact that this does not go through the origin, that's how you can tell it's not proportional. So there's a couple more to go. Let's talk about this now in terms of an equation or a rule. So let's go back up to our diagram. Well, we don't. Okay, here we are. The equation's right here. So if you kind of review what we have so far, it's 0, comma 0. It starts as the origin. So if you look at the rule, this kind of tells a similar tale. What this should tell us is that the rule itself doesn't have like a plus part. Okay, so like the C sub n. Oh, good lord. Okay, so what I mean is that the C of n, sorry, C as a function of n, is equal to 7n, and then we have this plus 0 part. And we have this plus 0 part because there is no number here. It starts as the origin. The way it's going to manifest itself. Oh. Good gravy. Okay. The way it manifests itself is just having the 7n part, not the plus anything part. In the same way, if you look over here at the non-proportional side, I do have this 7n, and then I'm going to have this plus part of like a plus 5. So that's how it shifts itself up on the graph. That's why it starts at 5 on the table. So again, if we're taking notes, what I mean is that the rule will just be this part, versus a rule over here will be more like this. Okay, so that's the part that makes it non-proportional. The fact there's nothing else here is what makes it proportional. Okay? So now the question remains, why is this important? Well, if we kind of think about a story, if you think about kind of the situation, the way you can tell proportional versus non-proportional is that you have no initial part. So over here you have kind of like initial amount. I mean, sometimes that's a fee, sometimes that's like a starting amount in your bank account, just something to start with. And here you start with nothing. And that's really the way you can tell them apart. So like if you look at the situation, over here it was just $7 per pizza. Well, on the right, we started with a $5 delivery charge. So over here, we start on the blue side, we start with nothing. On the right, we actually start with something. That's how you can tell proportional versus not proportional. Hope that clears things up. Thank you guys for watching. You guys have a great day.